Dear friends, Maths Aspirants is a collective of mathematics students, research scholars, postdoc fellows across India, initiated by myself in 2017. And we used to organize several online programs to help the students who prepare for different national level competitive examinations. As a part of the ongoing online problem solving session series, today we have a session on integral calculus. We blessed to have Dr. Nivetha Martin with us to handle the session. Dr. Nivetha is currently working as an assistant professor at Arul Anandar College, Autonomous College, Madurai, Tamil Nadu. Dr. Nivetha took her PhD from Bharatidasan University, Tamil Nadu, and MSc from Holy Cross College, Trichy. Dr. Nivetha already taken few sessions in our platform few years back. I'm sure that today's session will be really helpful for those who are seriously preparing for IIT JAM and other examinations. I would like to express my sincere thanks and gratitude to Dr. Nivetha for accepting our invitation and joining with us. I welcome everyone to this program. Welcome, Nivetha.
Thank you so much, sir. And it's really a wonderful opportunity for me to interact with the students, especially with focusing on preparation of examinations. And really, from the bottom of my heart, I express my sincere gratitude to sir, because you have given a very good opportunity and it is a very good initiative. And I'm so happy to be a part of it. So now, today we'll move on to, sir was telling, we'll go on with the integral calculus part, especially with the focus on IIT JAM. So, and everyone is busy with celebrating Diwali, and kindly bear with me the sounds of the crackers, which cannot be avoided. And really appreciate the students also, in spite of your holidays and all those things, your interest in getting attending the session. Really, it is a boon to me, and it is actually a boost to me also. So with no further delay, we'll move on to the session. So today we'll be focusing on the integral calculus part, especially for IIT JAM 2025, and a few tips to go on with the 2026. So every one of you will have a very fundamental knowledge of about what is integral calculus is all about. Because in your undergraduations, you might be able to just come these particular concepts in the very beginning of your semesters. So, you know, for sure, as we have a calculus and we can study calculus very deeply as differential calculus and integral calculus. So integral calculus, it is actually mainly dealing with the integration. To give a very simple understanding, it just goes with integration, and will go with an integrals and its own properties. So when someone asks a question, oh, what is integration? We automatically say that see, it is an inverse process of differentiation. If you differentiate a function, fine. And again, if you integrate, we get back to the function. So this is how we used to just have an understanding about integration and differentiation. So now when we go a little deeper into it, so what is an integral? See, what is the need to go on with the integral? So generally, whenever you are doing a problems of an integral, we always try to find it is an area under the curve in a graph. So that's how we are able to find. So from one particular lower limit to the upper limit, we just go with the integrand and we start integrating a function with respect to a single variable. So why do you want to do that? So what is the fundamental behind it? So here it is nothing but when we go with an understanding about the region covered by those things. So we always focus on finding area under a particular curve. So what is the curve is nothing but the function, what we want to go with that. So here we have to understand also about this particular concept, that is an antiderivative of a function f of x. So it is a function f of x. So the antiderivative. So we can also have an interpretation as in terms of antiderivative. So the derivative will be equal to f of x. So this is how we try to give an understanding of the integral in terms of having the touch of the differentiation also. So these are very fundamental and very light level. So now we'll go on with some types of integrals. But just it is like to breeze your mind and just to have a recollection and to have a refreshing about what we know about integral. So when we talk about integral, definitely we will be discussing about the definite integral. So when we talk integral, always we'll have the limits of the integral also, because it comes together, no? When we just say about the integral. So when we talk about the definite integral, we'll be very sure about, we're very definite about our lower limit and the upper limit. And suppose if it is not known to us, not having any upper or lower limit, we just say it is indefinite integral. So this is actually the understanding of your definite and your indefinite. So you will be getting an integrating constant when we deal with the indefinite integrals, but when we deal with the definite integrals, we don't worry about the constant because we get a very finite value as a resultant. So now this is something more, still again. So proper integral can also be called as a definite integral. The limits are finite, and we talk more about the function which is very continuous. So that is one additional aspect that we have to know about it. Then what is improper integral? So when we talk about the improper integral, so this is where we get such improper integrals. Okay. So and maybe the functions be continuous, not be bounded within a particular interval. So when we deal with that type of integrands and with the limits of this kind, we call that integral as an improper integral. So this is very, very basic. There is a fundamental theorem of calculus you'll be having here. So we talk about the antiderivative, and this is a thing, no? We'll have a their upper limit and lower limit. So this is a very simple one that we have been discussing, and we know for it. So these are some basic properties. So how you deal with your differentiation and integrations, they are the inverse of one another. Then when you take about the two different integrals with the same derivative, so how you can have a representations. And then we go with the linearity property, we'll go with the integral of sum of f of x plus g of x. So we can have the split of the integrals as two different integrals, and we can do it. So these are some of the basic properties that we deal about the integrals. And there are integration methods are there. So generally we always opt for integration by parts. We'll go with the integration by substitution, and something about the trigonometric identities, or some particular function will have an integration. So integration by partial fraction. So once when we are discussing something about the integration and all those things, we must be able to also be aware of the methods that what we are actually using to integrate the given integrands. So next so far we have discussed about the single integral. So now we go for a double integral. So when we talk about the double integral, so it always focuses on the area. So here we are having the integration with respect to two variables. So it could be a general, we take it as x and y, but it could be any combination of variables. So whenever we talk about double integrals, it is more on area. So when we talk about the triple integral, so when we have three integrals, so we always focus on the volume. So whenever we focus on double, we focus on the area. Whenever we focus on the triple, we focus on the volume. So suppose if you have learned even in your vector calculus, we go with the vector integration. So here that double integral and triple integral plays a more vital role. If we deal about the three integral theorems, or when we just go on with like Green-Stokes and Gauss divergence, all when we're discussing about that, those theorems will be connecting this double integral and triple integrals. So there also you'll be able to find what is the surface area and what is the volume of the region bounded, all those things. So this is how we have to understand about finding single integral, double integral, and triple integral. And this is more important, and this is we'll be quite using this. So the change in the order of integration. So if you just integrate, suppose if we have a double integral, whether you are going to integrate with respect to x and then y, or y but then with respect to x, it is going to be the same. So the order of integration is immaterial. It is not going to affect the end result of it. So I hope that these are the very fundamentals and basics that every one of us are very aware of it. But just to have a start with that, it is actually a customary to go on with a recollection of all the fundamentals and to make ourselves feel confident that okay, we know that actually the theory part of it. Now it's a time for us to step into the problem. So what I have taken is, see, I thought of presenting like this. So already I have made some presentations on the IIT JAM questions with a special focus on general calculus for the year 2023 and 2024 we are just discussing about. So I thought that this time we'll go with 2025. So and then how to prepare for 2026. So that is also very important, no? Because whenever we start preparing for any examinations, it is better to have a revival of what it has been asked so far. And definitely, most of the questions, no, whenever we are looking at the integral calculus, they are focusing on certain aspects, and they never leave that particular one in the question paper. It becomes a default question. So it is like from one pattern, they ask a question repeatedly. So we need not leave that particular one. So let us just follow the pattern. And what I was thinking that maybe discussing this 2025 questions will go on with the 2026. So some of the most expected questions and some of the things how they will be asking. So which are the areas or the concepts they are covering in that particular one. So like that, I thought we can have for it. And so this is a question. So this actually carries 2 marks, this particular question, because you have to give a numerical value because it is not simply a choose of the one. So here, if you are just going to look at the question, we have a function from R to R. So it is a continuous function. And that particular function is satisfying this given one. So integral 0 to pi by 4 sine of x, that is f of x plus cos x, integral 0 to x f of t dt and dx. That is given that the value is root 2. Okay. Now what I'm supposed to find? So now I have to find what is the value of limit 0 to pi by 4 f of x dx is equal to. So now they are very specific that they are seeking the answer just down to 2 decimal places. So if you just look at this particular question, no, maybe when you have so many of questions, we just look at the question, you may feel that, okay, how to go about with that? So how to just solve this particular problem? So here, when we just look such kind of problems, first of all, we have to think whether we can apply some of the standard results that what we know already or not. So that is more important. So only then we'll be able to go on with the actual thing. Okay, now we will just see this particular question. Okay. So now here it is given that you have given an integral like this. So one of the results of the fundamental theorem of calculus, so we have one particular result with that. So maybe as I write, you just see that whether you are able to recollect that particular result or not. So this is what we were talking about our antiderivative. Okay. So this is the how. So we have f of x is equal to integral 0 to x f of t dt. So f dash of x is equal to f of x. So this is something we go for the fundamental theorem of calculus will be there. So okay, now how to represent this using this result? So maybe this I'll have 0 to pi by 4. So I can have this as sin x. So instead of f of x, can I take it as f dash of x? Then let me retain cos x. So 0 to x f of t dt, can I have this as f of x? So now, what I personally feel, no, when I look at the question, inside the integral 0 to pi by 4, I have another one in integral of 0 to x f of t. Now that is a problem here. And because my f of t is not known, so how come I can able to simplify this one? So now when I'm using this particular result, when I take f of x is equal to 0 to x f of t dt and f dash of x is equal to f of x, look, my question becomes very simple. Now I am just getting rid of that particular integral, which was really something disturbing me. So now how can I just make so the retained value is the same. It's not going to get changed. It's root 2 only. So here there is not a problem. Simply I'm just rearranging my LHS. That's what I can say as of now. Okay, now how can I make this as? So this becomes 0 to pi by 4. If you just keenly look, no, sin of x, f dash of x plus cos x, f of x. So if you think for a while, definitely you will be writing this as d by dx of sin x, f of x. So here also I am not disturbing my right hand side. I'm just retaining the same thing. Now look at my left hand side, it has become 0 to pi by 4. So now it is very simple. Just now we were just recollecting that integration, differentiations. So they are going to be inverse and all those things. So we have been discussing and we have been recollecting one. So automatically, what happens here? So I think if I write this, it also makes sense. Yeah. So simple here it is. So now look at from very complicated left hand side. I have just brought you a very simple and easy to solve and easy to apply. Now what is left to me is I just want to apply only the limit. I just want to go with the applying of limit. So I need not worry about my lower limit because it is sign 0. So I just need not worry about that. So I'm getting retained with this. So what is the value of sine pi by 4? You know, it is 1 by root 2. So f of pi by 4. Okay, let me just retain f of pi by 4 here alone. And I become 2. Now you may have a question. What I'm supposed to do with f of pi by 4? Now what is my f of x? So my f of x is nothing but 0 to x. It is actually f of t dt or f of x dt. Okay, f of, you'll just have this. Now instead of f of pi by 4, I can simply write it is 0 to pi by 4. This is actually, it can be any variable. It is immaterial of x. It's 2. So now, yeah. So here, either if you're going to go on with the value, it is going to be 2. So it's a very simple one. So now, how did we solve this problem? We just to solve this problem, not with taking a lot of efforts in finding out this and that, but very simply we applied a known result, and then we started to simplify it step by step, and we were able to find the value of this. So this is actually equal to 2. Now we have the next question like this. So let
explain the last part.
yeah.
Can you explain the last part again?
Yes. You want me to just go on with this particular one?
Yes. How did you like say capital F of pi by 4 as integral 0 to pi by 4 f of x dx?
No, actually, yeah, very good question. So I was just telling you, no, we have actually a fundamental theorem of calculus of one of the things of interpretations. So we can have my f of x is equal to 0 to x, that is f of t dt, when we have f dash of x is equal to f of x. So this is one result that we have been having, and we have just applied the result over here. So now I'm having f of pi by 4. So instead of x, I taken as pi by 4 here. So already I have it as root 2 and root 2. So you can able to get the answer is what? 2. Is it fine?
Yes, ma'am.
Thank you. Good. So now we'll go with the next question. See, let omega be the solid bounded by the planes z equal to 0, y is equal to 0, x is equal to 1 by 2, 2y equal to x, and 2x plus y plus z equal to 4. Now, if V is the volume of omega, so they are just asking the value of 64V equal to. So again, they are asking us to round off to 2 decimals. See, this is very simple, but at the same time, when we just to focus on this one, how to find the integral value of it. All are actually the planes. So maybe last time I am not able to give a very appealing or a graphical presentations of it. But I like to give how do you visualize these things. So I thought that this will be very fine. Yeah. So now maybe I'm not going to give you or discuss something about the code what have been used over here, but simply to have an understanding, because whenever we simply deal with all those things, But I thought that this time, since we are having a lot of mathematical tools to visualize the things, so I thought that we could give a look like this. So we have taken some planes, whatever is given, because you take it as x equal to 0, y equal to 0, and x is equal to Yeah, 1 by 2, and y is equal to, that is 2y equal to x, so y is equal to x by 2. We have another one plane. So how the region will be there? So that's what is very important. No? So when you talk about this question, omega be the solid bounded by the planes of all those things, and then you are trying to go on with that. So how you will have that region? That's my thing. So when I'm going to see about the region, you will be able to see that the ABC, and you will be having another one thing of your A dash, B dash, and C dash. So we have just given all these planes, and you are able to construct the particular region which will be bounded. So now from which you can able to find the limits of this. So this is simply the graphical representations of about all those things that we have been done. So finally, you will be able to check up this one. So you can able to check how you are getting the limits of your Z, and how about your Y, and how about your X. So our focus is actually first on your Z. So your Z limits and your Y and X. So when we find a region of all those things, so this is the one. From this particular part and this particular part, you will be getting the omega region. So now we are going to find the integration of this. So how you can do that particular integration? So it is very simple one. And how we are going to do about this? See, the problem is very simple. When you are going to find the volume, so when you are going to find the volume, your volume will be nothing but it is your triple integral. So with respect to what you will be just go on with that. So you will be taking your dz and dy and dx. So this is actually the general way we do with that. Now what I want to find, all that I want to find is nothing but the limits. So what is the limits of z in terms of your x and y? So here one limit will be having your z equal to 0. And what about this? So this will be your 4 minus, you can take it as y minus 2x. So this will be your limits of your z. So what will be your limit of your 0? And that is your y. So you will have it as it is 0. So your y will be your x by 2. And what about your x? So definitely it is going to be 0 to 1 by 2. So this is a very simple one we are going to do with that. So how you can go with an integration? So it is a very, very, as usual, very simple integration. But however, let me just go on with that. So when you go with the integration of z, you will get only z. So you will have it is 0 to, it is 4 minus y minus 2x. You can have your dy and dx. So it is going to be so this is going to be again, so let me just, so it is 0 to x by 2. So it is going to be 4 minus y minus 2x. So again, I want to have the integration with respect to dy and then with your dx. So what happens when you go on with your dy? So this is going to be your 4y. This is going to be y squared by 2. It is 2y. Now I want to apply the limit of my x. Okay, so that is actually, I go with this here 4x by 2. So this becomes x square by 8. So again, it is going to be 2x square by 2. So this is a very simple one. So it is going to be your dx. So here it is going to be 0 to 1 by 2. It is 2x. So you can have here as, if you simplify, you will be getting minus 9x squared by 8 because 2 goes off. It is minus x squared by 8 minus x square. So you will be getting minus 9x squared by 8. You will have dx. So now what will be the next one? So here. So again, we are going to integrate with respect to, so it is 2x squared by 2. It is 9x³ by 3 into 8. Okay. So the limit is actually 0 to 1/2. So maybe if you go with a simplification, so I think I can get this, it is x square. It is going to be 3x³ by 8. And that is going to be your 0 to 1/2. So here it is going to be 1/4. Here it is going to be 3. So it is 1/8. It is going to be 64. So if you take the LCM and all those things, I think you will be getting 16 minus 3 by 64. It is going to be 13 by 64. So now this is actually your V. That's how we are able to find. But what is your question? Your V is given, but they are asking you to find the value of 64V. So what will be your 64V? If V is equal to 13 by 64, so definitely your 64V will be, so 64 into 13 by 64, I think you'll be have the answer is 13. So look, it is a very simple problem. So very directly you can able to find. So what I'm trying to say is definitely you will be getting a problem of finding the volume. So the volume integral where you deal about with the triple, no, the integrals and finding the limits. So this is one of the questions which I'm actually seeing every time you will be getting one triple integral. So you can be very sure of that, and you can have in mind that triple integral problem. So you should be able to very quick in integration. So this is how you can do it. So here there are not much any shortcuts and then, but very quick in integrating, and you'll be able to find the results of it. So this is a simple one.
How did you get the lower limit of x equal to 0?
When you, okay, I will just see that once again. See, that's what. See, you are actually, maybe I'll go with this one. See, when you take your z equal to 0 and y equal to 0, and you just check what happened when your y equal to 0 in the sense, what is your x of c?
0.
So you have to find, yeah, so that is a relationship is given with that. So with that only you are able to get our limits with your x is equal to 0 to 1/2. Okay?
Okay, ma'am. Thank you.
So now we'll go with the other question. So here T denote the triangle in the xy plane. So this again another one very simple, and at the same time it is quite easy also. We'll go on with that. Yeah. So like T denote the triangle in the xy plane bounded by the x-axis and the lines y equal to x and x is equal to 1. So I think this is a very easy one that you can able to graph on yourself. So you talk about this one. When you take x is equal to 1, maybe I'll take the entire one here. So when you take x is equal to 1, okay, fine, you can have x is equal to 1. And when you have y is equal to x. So this is a line, y is equal to x, and you have this is a 1, x is equal to 1 here. And of course, bounded by the x-axis, it is nothing but what your y equal to 0. Okay, fine. So now you are going to find what will be the value of this double integral. So what is the value of the double integrals? Now I want to find the limits of this particular one. So what could be the limits of this one? So it is 5 minus y. It is going to be dx and dy. So either I want to find the limits of x in terms of y, and y must be the constant. So this is the understanding of it. So how can I just do with this? Now you can think about changing the order of integration, but here I think it's very simple that you can go on with this. So if I want to find the limits of x, there is a saying that you have to draw the horizontal strips and you want to check from where your limits are applying. And if you want to find the limits of y, you want to draw the vertical strips. So this is a way that we have been taught to find the limits of x. So maybe we'll follow the same thing. There is nothing wrong in that. So if I find the limits of x, now can anyone tell me what will be the limit of x? So from where, if I'm drawing this particular strip,
0 to 1.
Yeah.
0 to 1.
Maybe I'm asking you, if you draw the horizontal strip, you will be drawing the strip from
Y
this
to 1.
particular one. Yeah, very
It's
good.
x to 1.
No, maybe I'll say that. Maybe if I'm right, I think you can just x limits. If I'm going to say, can I say it varies from y to 1?
Yes,
Yes.
ma'am.
Yeah, very good. So what will be your y limit then?
0 to 1.
Exactly. So it is going to be 0 to 1. So here let me have it as y to 1 and it is going to be 0 to 1. So definitely this integration is going to be very simple because the limits are very easy. They are very simple integrand also we have. So I think you'll be having it as 5x. So you can go with your xy. So I think you will have it as y to 1. You have it as your 0 to 1 here, you have dy. So here, if I'm going to apply the upper limit, it is going to be 5 minus y. So it is going to be 5y. That is going to be plus y square. So it is going to be 0 to 1 dy. So if you're going to integrate, I think it's very simple, no? Because you will go with your 5y. So it is going to be y square by 2. So minus again it is 5y square by 2. So we can just simplify this one to make it very simple. So it is 3. So when I go with the 0 to 1, so maybe if anyone is quick in answering, you can also give an answer and you can have a check. So it is going to be 5. It is going to be 3 plus 1 by 3. So it is 2 plus 1 by 3. So the answer is 7 by 3, though it is 2.33. Yeah. So it's very simple. So you see, last time, no, in for integral calculus alone, they have been asking some 10 to 12 marks around. So this is a very simple problem that you can do it very easily with just a simple graph of it and you can get the limits. So I think these are some places that where you can score easily. Even the previous problem also, it is not a much big difficult one unless otherwise it takes some time for us to go over the integration. But the problem is easy to understand. It is not much twisting and it is not much very difficult to even understand, but it is very easy for us to have an understanding with this. Okay, now we have another one problem. And all these are numerical values you want to enter it. So that's the thing here. So let S be the surface area of the portion of the plane which lies inside the cylinder. So maybe even I like to just go on with this one. Okay. So let me go on with the thing. One second. I think I'm getting the same thing. Okay. So maybe if you just have the portion of the plane. So it is nothing but z equal to x plus y plus 3. So we can just have with that. So I think the equation of the plane is fine. So you go with cylinder. So okay. So now we have a plane, we have a cylinder. So what do actually we are asked to find? We are actually asked to find so we are asked to find the surface area of the portion of the plane. It is lying inside the cylinder. So if you just look at this particular one, the surface of the plane, it is actually lying inside the cylinder. So look at this particular one. I think if I'm just going to go on with that, this particular part, maybe I'll have the cylinder alone. So the particular part of this portion, no, which is encircled by like this region, like a circle. So when you let's just see like this, okay. So that particular part of the plane, it is being found inside the cylinder. Now I am asked to find what will be the surface area of this. So this is the understanding of the question. So it is a very, very simple question. Very simple question, because we are asked to find the surface area. And what will be the things? So if I'm just going to take the surface area, so whenever I talk about the area, no, I must be able to just to say that, okay, what is that particular one? Okay. So if I'm just going to see this one, I'll go on with the area. So whenever I talk about area, I have to see either of any of the regions. So it could be either the z equal to 0 plane, or it could be xy plane, or yz or zx or something, because it's an area. So I'm very clear that I have to go only with a double integral. So where it is going to lie on with that? So generally, when you talk about the reflection of this one in your xy plane, that is your z equal to 0. So it is simply, it is going to be what? It's going to be a circle. I should say that. Definitely it is going to be a circle, because you look at the equation of a cylinder. Your equation of a cylinder, what is actually your x square plus y square equal to 1. So I can simply say it is r equal to 1. And I'm just going to project that particular one into what? The xy plane. So that is an understanding of this particular problem. I just wish you to have an visualization of this problem, so that it will be for easy to understand. So what I'm going to do and all those things. So when this is going to be there, so how to take about this problem? So now we have seen what is the plane here and what is the cylinder there, and the plane part of the lying inside the cylinder, we are going to find the surface area of it. Okay, fine. And now whenever we talk about the surface area, I want to project it, or I want to have it is confined to any of the regions. When I talk about regions here, it is going to be your xy, or it is going to yz, but generally we always go for what you were xy. So that is an understanding with that. So now how to take up this problem? Okay, so how to take up this particular problem? So it is very simple. It is very simple, because my question is surface area. My question is what is the surface area of this one? So whenever you have the surface area and like this, so you have a formula like that. It is going to be some region. So you're going to find, and it is going to be, it is 1 plus dou z by dou x the whole square, and it is going to be dou z by dou y the whole square, and it is going to be that particular area. So whatever is going to be here. So it is going to be here dx dy here. So of course there is no doubt in that. Now, what is my z? So z is nothing but it is your x plus y plus 3. So you are very sure what is your dou z by dou x. You are very sure what is your dou z by dou y. So what happens to your integrand? So your integrand is nothing but what? It is 1 plus 1 plus 1, and it is going to be your du. And now that is going to be what? It is actually your root 3. But you are very sure what is your area. It's a circle, because I'm just going to have a projection of it into the xy plane. So definitely it is going to be r is equal to 1. So when I take r is equal to 1 here, because it is x square plus y square, so we take it as, it is generally r square, but here it is r is equal to 1 here. So what happens here? So definitely this is going to be root 3. I can take it as outside, and this is going to be pi r square. So it is going to be pi a square. So it is going to be r is equal to 1 here. So the problem has got over. Okay, fine. I have found the surface area. So what else? So my thing is, I'm not asked to find the surface area. I'm asked to find what is the value equal to s by pi the whole square. Okay, this is going to be my s. So s by pi the whole square. So s by pi the whole square. So you know for sure that what is your s? It is going to be root 3 by pi, and it is a whole square. So it is root 3 the whole square. It is going to be 3. So here, what is the hint for us? The hint is a surface area. So whenever I'm having a surface area, I can able to go on with this particular expression and I can easily find the answer. So it's a very simple problem. So this is a hint I am remembering this. So now we'll move on to the next problem. Yeah. This is another interesting problem. So again, the very first problem that we have seen, isn't it? So whenever we see that integrand inside, that gives us little a disturbance may be there, because look at the previous problem, it was at least easy to understand. Okay, fine, this is how we are going to do that, and the previous problems are fine. But whenever we come across the problems of this kind, like phi of x equal to 0 to x, that is the integral 0 to x phi of t dt plus sine x and all those things. And now you have another one to be found as x tends to pi by 2, what is the value of 2 phi of x minus e power x is equal to. So already 5, it is given as a function because it is a continuous function is defined with that. Okay, but we don't know what actually my phi of t is. Now how to go with this problem? See, as I was telling a little earlier, whenever we come across this problem, we'll try to bring the problem into a form which is very familiar to us. So that is very important, which is very familiar to us. We have to be able to find it. So now I have an equation. So how to bring this to a very familiar one? So that's a question. Okay. So I have this particular one to go about with this. Okay, let me start with this one. See, whenever you have such kind of questions, we'll try to bring to a form using what? Some differentiations. Okay. Now, maybe I pose the same question to you. I've just given a hint, differentiation. So what I can do so that I can able to bring this to an easier form or to a familiar form. Any idea?
Fundamental theorem of calculus and bringing into differential equation.
So exactly, very good. So we'll go with that particular try. So now, if I'm going to go with the differentiation of it, okay, now what? How can I make that? So maybe let me write this expression. You check whether it is convincing and it is right. Okay, suppose I'm able finding phi dash of x. So this becomes actually phi of t. Go with 0 to x plus cos x. Okay. So what I've done, I have just found the derivation of this entire expression. Now, when I take about phi dash of x, it becomes phi of x minus phi of 0. It is cos x. Now, what is phi of 0 value? Any idea?
It's 0.
Very good. Because your phi of x is given here. So phi of 0, so 0 to 0. We need not worry about the integrand phi of t at all, because both your upper limit learned as 0. So automatically the 0. And what about your sine 0, 0? So your phi of 0 is going to be 0. So now, if you just go on with that, this is going to be your phi dash of x. It is going to be phi of x plus cos x. I think this form will give you a picture of this one. Yes. So we'll go with the linear differential equation of form. So phi dash of x equal to phi of x plus cos x. So something, no, it is relating to this form we have brought it. I think this form is very, very familiar to us. It is very simple. Can anyone tell me the general solution of this particular one, the form of solution, how this particular linear differential equation will be there?
Y into integrating factor.
Very good. So we'll go
Uh,
with the e power integral p dx, no? So that's how you
Yes,
find
ma'am.
it. So it is
Yes,
q
ma'am.
into, yeah.
Integrating
So p
factor.
dx. So we'll have an integrating
Plus
constant. Yeah.
Yes, ma'am.
Very good, very good. So now look, the problem is very simple. Now you cut this particular question, it is something frightening us, no, at the very first strike. Oh my God, how am I going to do that? But as we are just going to look deeper into it and trying to apply your FTC, that is your theorem of calculus. And I think it's very simple that you can able to bring to a more familiar form. So I can able to find the integrating factor of this one. So I think here you can have here to be. So you can have this to be your phi of x. So it is actually your p value is -1. So it is going to be minus x. So again, it is going to be e power minus x. You have cos x and you have k. Now the next one is how to find a solution for this. So very simple. So maybe let me take it as I. So I'll go with e power minus x cos x dx. Okay. So maybe I can take, generally you will take the light form, no? So u is equal to cos x, you will be having, and you will have dv equal to e power minus dx you will have. So du will be equal to minus sin x dx, and your v will be equal to minus e power minus x. So again, the integration by parts will have uv minus integral v du. So this is a very simple and most common method of integration that we'll be applying for this product of the functions where an integrand is there. Okay, now when you talk about uv, I think you'll go about it is minus e power minus x, it is cos x. So minus, so it is again minus e power minus x, so it is du. So you have it as plus, so it becomes sin x dx. So this is again one, and I have the retention of I here. So once again, we have to do the same thing. So now in this case, I take u is equal to sin x. So again, dv will be equal to e power minus dx. So your du will be equal to cos x, and dx you'll have, and your v will be equal to minus e power minus x. So here we have the same thing. So this part I'm going to have minus e power minus x, it is cos x. So this is going to be minus. So I'll have the thing. So uv again I'll be having. So it is minus e power minus x sin x. So again minus integral v du. So minus e power minus x. So du will be equal to your cos x dx. So what happens now? So we should be a little cautious because we have so much minus signs and all this there. So we go about, so here we will have it as minus is actually plus you will have, so e power minus x sin x. So you have 3 minus, so you'll have minus, so it is nothing but it is e power minus x cos x dx. You have your I. Now, what is your I is actually? Initially we have taken I to be integral e power minus x cos x dx. So look, again you have this particular I over here. So I think this becomes 2i, and it becomes, so I can take e power minus x outside. So I have sin x minus cos x. Okay. So initially, no, the equation what I was having is nothing but it is e power minus x cos x plus k. Can anyone tell me how to go with the next step? And your I, what you have taken initially is e power minus x cos x dx.
We should use the initial condition and find the k value.
Very good that you're telling that you want to find the k value is right. Still more, very closer you are there. How to go with the next step? Because I have I is equal to, I have 2i and all those things it is there. So any idea? Maybe let me write and you just to see whether you are able to catch hold of the things. See, this is e power minus x cos x. And this is my I actually. So it is I plus k. But I do have my expression for I. So what is my I? I is nothing but e power minus x. It is sin x minus cos x by 2 plus k. This is going to be my phi of x e power minus x. So now I am just taking like this. I hope this step is also clear to you. Now, if you want to find the k value, as someone was rightly said, I want to go on with my initial condition. So what is my phi of 0? So phi of 0, I can have it as 0 actually. Okay. Sine 0, 0. So minus 1 by 2, e power 0 is 1. So my k value will be 1 by 2. So now I have found what is the constant k value. So now this becomes phi of x is equal to sin x minus cos x by 2. So it is e power x by 2. So now I can take 2 phi of x. This becomes sin x minus cos x plus e power x. So we are trying to bring to our question. Now if you check, this is the question. So 2 phi of x minus e power x. Now as x tends to pi by 2. So when limit x tends to pi by 2 here, so it is 2 phi of x minus e power x. Can anyone tell me the answer?
1, ma'am.
Very good. So you are getting the answer of for this particular one. It is going to be option A. It is going to be 1. So again a small note I want to make it. So whenever you are coming across then integrand in the questions and the integral of an integral like that integrand, again you have integral. So don't get panic. You just think for a minute and you just see how that you can able to bring this problem to a very simple form so that you can able to find the solution to it. So now we are trying to bring the question itself. We don't have a very direct one. So simply we are not given expression of 2 and all those things, but eventually we simplify this and we try to bring and we are able to get the answer is actually 1 here. So this problem is simple. Okay. So now we have another one problem. So we have the problem of omega be the bounded region in R cube. So it is lying in the first octant. So this is very important here. So it is lying in the first octant and you are asked to find what is the volume. So whenever the volume of omega, it is being asked over here. So you know for sure that we have to make use of what? The triple integral. So there is no doubt in that. So whenever we are asked to know the surface area, I was just telling you, you go about with your double integral, and whenever you go with your volume, you go with your triple integral and all those things. So this is a way that you must find that somehow you are going to find solve a problem of triple integral. Okay, then how you can make it? So how you can do it? So this is a very simple one, but the same way I like to just go on with the visualization of that. I think yeah. So this is a problem that what is given to us. You see. Now what is actually the problem? So we are actually find the omega. So what is omega here? So omega is a bounded region. Okay, it is lying in the first octant. First octant where all the values are positive. Your x, y, and z. So every variable is going to take only the positive values here. So you are able to just go on with this. Okay. Now it is bounded by the surfaces. So what are the surfaces? You have z equal to x square plus y square, a surface. And you have z equal to 4 is a planar one. And again, you have x equal to 0, y equal to 0. So all the values are given to you. So there is no much difficult in getting into the problem. Okay, now if I want to imagine or I want to visualize how this particular one will be there, okay, now you have a plane is equal to 4, and you have the surface is equal to x square plus y square. So looks like a conic one. You have this over here, and then how to put an intersecting path between these two plane and actually a quadratic surface is there. And now you are able to get one particular circle. If you see, you are able to get one particular circle. But my focus is actually not on the whole entire circle. Now I am limiting the particular circle, no, where it lies in the first octant. So when I lies in the first octant, can you tell me what will be that region? So that's why I'm able to, I was just giving you a picturization of this particular one. Suppose if it is going to be only in first octant. So where you are x, y, z is going to be a very positive one. Okay. So when you talk about that particular one, and I used to say no. So whenever you go on with the projection of it. So now this particular is getting projected into your xy plane. And you are going to focus on what your x greater than or equal to 0, y greater than or equal to 0. Can you tell me what could be that part we are going to focus? Yeah, students? Any idea? See, what is given in the question? I have just given you a pictorial representation. You have a plane intersecting the surface of cone. Okay, you are able to get the circle as a part of the intersection is there. And we are going to get projected into your xy plane. So xy plane where you have only your positive ones. Your x is positive ones and your y is positive ones. You just tell me. If you just look at like this, you have your x positive, your y positive. What particular one alone you are going to focus? Any idea? Definitely this is going to be a circle. There is no doubt. But confining to the positives.
Only in the first octant as given in the
Yeah,
question.
very good. It's a first octant.
Below
So-
the circle and above the parabola.
Yeah, you're very right. So you are going to focus not the entire circle, but the portion of the circle which is assuming only the positive values of your x and y, because now we are discussing something on the projection into your xy plane. So that is very important. So that part when I'm just going to see, I think it is going to be only a quarter disk of it. A quarter of it only we are going to look into it. So not the whole one, we are going to have only a quarter of it. So have in just a mind. Okay, so just have in mind that because when you discuss the limits, you must not get a question how we got the limits. So we are not focusing on the entire circle. We are focusing on the portion of a circle which satisfies the conditions of what? X greater than or equal to 0, y greater than or equal to 0. So that is very important here. So in that way, the limits will be varying it. Okay. So now I think the pictorial representations may be facilitating for you to understand a little more better. When I'm just saying that it covers only this part and this doesn't cover this part. So I think this will be aiding you a bit. So now how you are going to go about with your the computation part. So how you are going to calculate your volume. So that is very important. So as I was just telling you, so you can go on with your V, that is your volume. So your volume will be your dz, dx or dy or dy or dx. It's not a problem. As I was mentioning earlier, the area, that is the order of the integration is not a problem at all. So I'm just going to take that. Okay. So whenever I take dx, dy, so it means that it's focusing on area. So now what are my limits? So if I'm just going to say the limits of z are given already. See, that's what we have to understand. So the limits of z are given already because you have z equal to x square plus y square to z equal to 4. So that was actually the pictorial representations when you are going about with that. So here it is z is ranging from. So maybe I can take x square plus y square equal to r square, maybe for easier computation purpose, because when the pictorial representation you understood that the projection of it is going to be what? A circle. So only I can just go and take x square plus y square equal to r square here. Okay, when I take that, so I think I can have z equal to r square to z equal to 4. So that way, if I'm just able to take the limits of it, so it is going to be r square to 4. Or you can write it is going to be x square plus y square to 4. It doesn't make any much difference of it. So this dx dy, no, maybe we can have, this is going to be what actually, it is an area. So circle that I'm just going to focus, but it is not the whole one. It is not the whole one. And so I can just go about with actually here, it is going to be your r. So what can you write your dx dy? So we'll just better convert into a polar form, so it will be easy for us. So I can have it as r dr d theta. So what is your r here? So your r, so z equal to, you're going to have 4. So it is x square plus y square equal to 4 you will have. So I can take my r will be equal to what? 2. So it is going to be 0 to 2. Generally, this is the limit of 0 to r. And what about the generally, if it is a circle, we will be taking 0 to 2 pi. But now it is only a quarter of it, so I'm just going to take 0 to pi by 2. So this is the limits of it, and this is how I'm just going to proceed with that. So now
Theta will be 0 to pi by 4, right, ma'am? Because we're taking the quarter part.
no, actually you just to see the complete revolution is actually 2 pi. Am I right?
Yes, ma'am.
Yeah. So when you take a half a revolution or half a rotation of it, what you will take?
0 to pi.
Even half of it?
0 to pi by 2.
Yeah. So now can you understand why did I put the angle to be pi by 2?
No, ma'am, because quarter part means in that pi
No.
by 2 itself another
See, you
half
are taking the value was pi by 4. It is not that. See, the complete is actually 2 pi. When you take it as pi, then it is going to be no. So if you take only 0 to pi by 2, no, it will be there. Can you able to understand? Even half of it only is pi by 4. Okay. So
yes, ma'am.
yeah. So now this is going to be 0 to pi by 2, 0 to, and it is r square to 4. Now you see, my integrand is very simple. My integration limits also very simple. It's very easy. So now simply I can just go about with the 0 to pi by 2. It is actually 0 to 2 here. So when I integrate first with respect to z, so what I can get, I can just simply get it is 4 minus r square. Simple. I do not much worry about it. So dx dy, it is going to be r dr d theta. That is the understanding. So now I'm just going to take it as it is going to be 0 to pi by 2. So it is 0 to 2 you will have. Okay. So maybe I can have it as 4r minus r cube. So I can have it as dr d theta. So this is going to be 0 to pi by 2. And how I can bring about this particular one. So it is a simple integration. So maybe I can take this as 4r. So I think you will be getting 4r square by 2. So it is 2r square. And here it is going to be r power 4 by 4. And here it is going to be 0 to 2 and we have d theta.
RQ by 3.
Yeah. Okay. So now can you just tell me what could be this particular one? So 0 to pi by 2. So it is r square, it is 4, it is going to be 8. And r power 4 by 4. So 2 power 4 by 4. So can you check this value and can you tell me what could be this particular value over here?
7.
Yeah.
1 1. It
Yeah,
is
it is 2 power 4. I think 2
sorry.
power 4 it
4,
is
ma'am.
16. Yeah. So you will be having
4.
here it
It
as
is 4.
Yeah. So you'll have it as d theta. So I think this value becomes 4 and it is 0 to pi by 2. It is d theta. So it is very simple. No, it is 4 into pi by 2. So I think it becomes 2 pi. Yeah. So the answer to this particular problem is going to be 2 pi. So look, the problem is actually simple, but it demands little calculation. And we need not have the limits in terms of y and x and all those things. So just to understand what will be the reflection of that particular one, the xy plane. So what could be the surface of it? So this makes a problem little simple. But as usual, I'm telling you, no, whenever you discuss something about integration, you must be able to solve it quickly so that you can save time. Okay. Yeah. So we'll go about this particular problem. So yeah. So this is a problem where it is integral 0 to 1, integral root pi to 1, 3 e power x cube dx dy. So look at this particular integrand. I think the limits are at least okay, but the integrand is okay. How you can go with integration of this particular function, it is 3 e power x cube. So you want to, first of all, graph what is given in the limits, because your x is root y and x is 1 and y is equal to 0 and y is equal to 1. So let us just think how we can go about with this problem. See, it is actually very simple, but if you start graphing it, so that's what I can say. See, you can have your x is equal to 1, okay, x is equal to root y, okay, so y is equal to 0 and y is equal to 1. When we talk about y equal to 0, okay, it's an x-axis. If I take y is equal to 1, okay, when I take x is equal to 1 is okay, this is going to be y is equal to 1, this is going to be x is equal to 1. So x is equal to root y, can I take it as x square equal to y, so that it's easy for me to go about with that. So definitely x square equal to y, if I take maybe one part, I'll be getting this, because I need a region which is bounded by all those things. No? So definitely this will be the region. So you see, this is a kind of diagram I've already drawn, but I think I have not drawn y is equal to 1 alone. So in most of my experience, no, after getting in touch with math aspirants and preparing for integral calculus in deeper with IIT JAM questions, at least 1 or 2 problems, no, you are getting of based on this particular setup of diagram. Based on this particular graphical one, you are getting at least 1 or 2 problems, you'll be getting it. Somehow you will be getting it. So that's what I'm just seeing it. So it feels that I'm just drawing the same graph again for different problems. So it means that the limits, what it is being there, what is given. So it is simply repeated for the different integrands. So this is what I am trying to give you an impression. So you must be very familiar in graphing it and getting the limits immediately. And I'm for sure that you guys are very intelligent and or good intellectual and active, and will be able to go ahead also. So now, so this is a very simple one. Now the limit given here is dx dy. Okay. But with this dx dy, you just see whether can I integrate or not. Okay, with respect to x, I think it is a tough one. I cannot integrate it as easy as with the other integrands what we have come across. So when we have to go for change of order of integration, we had a similar problem also. That is double integral over t, phi minus y, something, the same diagram I was drawing. That time we didn't go for change of order of integration. We just started to find the limit of x in terms of y and y in terms of constant. We started proceeding with it. We got the answer. Not a problem. But here, moving with the integrand is a problem. So it doesn't mean that whenever you are given a double integral with a definite limits and all those things, you have to go for a change of order of integration. It is not so of that kind. It is certainly not so. But then when to go? When to go when you are having a difficulty in going on with the integration with your integrand is your problem. Now, with these limits, going with the integration is not a piece of cake. It's not going to be an easy one. It's a tough to me. To every one of us, it is going to be a tough only. So now, what can I do to resolve this? So now I can apply what? The change of order of integration. So definitely I have to apply it. Now what will I do? Now, instead of given dx dy, I will go for what? Dy dx. Okay. If I go for dy dx, what should I do? Very simple. You want to have your limits of y in terms of x and the limits of x as constants. So this is what I'm going to do with. Okay, now you do the part. The integrand will not change. It remains as such. Now, see, it's very simple, no? Because everywhere the limit of x, it is going to end with only 1. That is not a problem. And also with the y, that is also not a problem. So I can just close my eyes and simply say that the limit of x, I can take it as 0 to 1. Okay, fine. I can just go on with that. But then, what about my y? I want to get in terms of x. So what will I do? I will start drawing a vertical strip. If I start drawing the vertical strip, okay, so it starts with this. So what is this particular one? And this is going to be y is equal to 0 because it's an x-axis when I start drawing like this. So x-axis, definitely y is going to be 0. Okay. So here it is going to be, y is going to be in terms of what? Your x square. In one problem, we are retaining x is equal to root y and we are proceeding with that. But here, we are going with the what, x square. So we are going with the limit of what? X square. Okay, now what is the use of doing this? This is going to simplify my integration. Yes, this is certainly going to simplify your integration because the given integrand is going to be a complete function of x. Even if you take the constant it is going to be a complete function of x. Okay. So now if I'm going to integrate with respect to y, what happens? So you will have like this. This is how you can write for our understanding. Okay, and then you go with your dx. Okay, now if I'm going to integrate only with respect to y, what happens? So it becomes 0 to 1. This is going to be 3 e power x cube and it is going to be dy. So it is going to be x square dx. Okay, now we got actually the particular limit here as 0 to 1 for x. And this is my integrand so far. Now is it simple? Yeah, you can use substitution. So you will take x cube equal to t. Okay. So since the limit is 0, 1, 1, there is no problem with the change of limit. It remains as a 0, 1. It remains as such. So it is x cube equal to t here. Now what happens over here? So okay, I'll go with the 3x square dx is going to be dt. Okay. So that's not a problem here. So now what happens? So it is 0 to 1, no problem. X cube, I'm going to have it as, that is e power t. 3x square dx is going to be dt. So look at my integrand. It has gone such a simple integration, no? Very simple integration. So this is going to be e power t and it is going to be 0 to 1. So it is e power 1, e power 0, it is going to be actually 1. So what is the answer? E minus 1. The very first option. So I think most of the choose no, you are getting only first option. I think most of 1 or 2 what we are seeing, most of the first options you are getting. Okay. So this is a very, very simple problem. So what I want to give you an idea is, just whenever you are seeing like this, please don't have a thought that we have to go for a change of order of integration. That's not essential. You can proceed with the given limits itself. But when you feel the integrand is complicated, not able to give a clear picture of how to integrate about that, then you can give a try of what? Going for the change of order of integration. So these are the questions that has been asked in 2025 IIT JAM with respect to integral calculus. I think to some extent I have convinced you with the previous year question paper about how you can handle the problems. Now, what to focus for your IIT JAM 2026, and it is a way forward for preparation. So this is what I like to throw some light onto it. Maybe I'll go from the scratch of it. So most repeated questions, where are they from? So you are getting area of curves, as I was telling, the change of order of integration, surface area, double integral, the solved by a triple integral. Then again, you will have some applications of triple integrals. Okay. But to the best of my knowledge, what I've seen a few years of question papers, you will be getting some surface area question, one change of order of integration, then definitely one triple integral. These are some standard one. Remaining other problems, you will be getting it. You will be getting it, but it may be any of the kinds that may fall, but some standard questions, maybe sometimes can be optional also. It may or may not be, but very definitely these questions are quite repeated. Even I personally, I can share with you, because my students are not that much, but the college I'm just not having much exposure to IIT JAM or questions, that preparations. We are actually encouraging them to go on with that, and from our end. So when I'm just stepping into for your preparing, no, your IIT or JAM question papers, when we are seeing, the very first time when I started looking into it, I feel something it is going to be little difficult for the students. But as we are familiarizing with the questions, no, what I'm able to come to a picture is they are asking some repeated questions of the same pattern. That is the thing that we are doing. It's not the same questions I'm telling you, but the same pattern of the questions they are following it. So when we just identify that pattern, so what is that pattern? This is a pattern here. So you'll be having that surface area or a change of order integration. So even I used to tell my children also, my students also, so you prepare all this for IIT and all those things. So they will be telling that, no, it will be a little tough on all this. I used to say, it's not going to be tough, but they will be asking the questions a bit to one. It's not much direct will be there. We have to go with an applications of some results. So it will be easy for them to understand. So I place a record that you finally start focusing on these things. When you prepare, you must be able to prepare the questions in such a way that you will be able to come out and clear the problems of the change of order of integration, surface areas, and different areas. So don't leave these questions. So give a good focus onto it. So when I was just browsing for some repeated questions or some standard questions, so I just came across few questions. So now I think that these questions also will be helping you in preparing. So you may not miss these kind of questions or a model of these questions. So that's what I like to place it. So when you look at this particular one, so the value of ∬G over G log of x square plus y square by x square plus y square dx dy, where the region is given where x comma belong to R square such that it is 1 less than or equal to x square plus y square less than or equal to e square. So okay, it is something, no? It just talk about you are going to find the area because it is double integral. There is no doubt. It's very clear picture it gives. But where the area is lying. So the area is lying between. So area of the curves. Okay, area between these two curves where it is actually lying and all those things. So that particular problem, as it has been said that it is more repeated. So such kinds of questions are also being there. So now, how you can bring about this particular problem? So this is a very simple one. So I can just say that it actually gives you, yeah. So now you want to find what is the region. See, when you look deeply, no, x square plus y square. It is something, it is a circle, has a center in the origin. And now look at the radius. It is e square. So 1, and it is less than or equal to x square plus y square, that particular part. So it is telling about your r. That is your r square. Your r square is lying between 1 and e square. That's what we have to understand from the given question. So it is a circle and the radius is given. See, this is where we have to understand. The questions are not very direct. So it is not telling that, so you have a circle and you have its radius between these. No, it is not telling all these things. It's very giving you a picture from which you want to make some interpretation. So this makes a difference between your IIT JAM questions and the other normal questions what we come across in our day examinations, in our college exams and test talk. This is what even I tell my students. So this is how they present the questions to us. Okay, so a little tricky it will be there, but when you are familiarizing with a similar type of questions, I think it is easy for you to just play with the same trick. So it is going to be your x square plus y square. So here, so you just have a diagram of this. So you have a circle with a radius 1 unit. So it is e square. So it is going to be e. Okay. So what will be this one? This is the one. This is how you are going to find. So it is going to be your 1. This is going to be your e. So now let us try. See, now again I'm telling you, once you are trying to fix, okay, it's a circle, you please leave out from your Cartesian x square y square, you can't leave it. You go to the polar form. So what is your polar form? It is going to be r theta. So that's what I'm telling you. So it is 1 less than or equal to r square less than e square. So it is 1 less than or equal to r less than or equal to e. So it is going to be a circle. So our problem is over. It is 1 to e. So what is your theta? So no description about the region where it lies on. It's simply a circle. So definitely your theta will be lying between these two. Okay, now everything is very clear. I have two integrals, that is double integral I have dx dy. Now instead of dx dy, I have to put r dr d theta as a standard form. It is a result which I know. So then I can make this integral very simple. So what is this integral? It is going to be there. It is going to be your log. It is going to be x square plus y square. And this is going to be your x square plus y square. Okay. So here you have dx dy. So this is going to be the one. Now how to go about it? So nothing to worry. First of all, you bring to the polar form wherever you have x square plus y square. You go with this one. This r limit, no, you go with the 1 to e and you go with the 0 to 2 pi. Now you just tell me, this is going to be, okay, r goes off. So how to simplify the integrand? So this is going to be 0 to 2 pi. It is going to be 1 to e. It is going to be log of r square by r. This is going to be dr and d theta. So very simple it is going to be there. Now what I'm going to do? So here, again, it is going to play a very vital role. Now, what is my r square? R square, I can just go on with what my, if I put r square is equal to t, again, I'll have 2r dt. So what happens to there? It's a problem. So let me go on with actually, yeah. So I can just go with this. So maybe I can take your maybe I can go with another one thing. Shall I go with for the simplification process? Instead of just dealing with this one, let me apply the log rule. Can I take it as 2 log of r by r? It is going to be dr d theta. I think this makes even more simple. Instead of going with the r square or log r square, no, the r square term, you just go on with that. So maybe you can go with the log r, you can take it as some u. So I can take 1 by r dr, can I take it as some du? Okay. So maybe I can bring this 2 outside. It is going to be 0 to 2 pi. So the limit is a problem here because I'm taking log r is equal to u. So I want to be very careful about it. So log r, I can take it as u. Dr by r. Can I take it as du? D theta. Now can someone tell me r is equal to 1? What will be my u limit? R equal to 0, what will be my u value? Any idea? Because it's very simple. And this is a relation. So I just made one thing. It is going to be 0 to e here. So r equal to, I'm sorry, I think I'll have 1.
1 to e.
Yeah. So 1e. So what happened? My u value. So when your r is equal to 1,
0 to
what is the log 1?
0.
0. Correct. So when your
Zero
r
to
is
e.
equal to e,
If r
log
equal to e, u equal to 1.
excellent. So it is going to be 1. So your 1 to e becomes 0 to 1. Now you see the integrand is very simple. So I can take this to be 0 to 2 pi, and I take maybe I take u square by 2. So 0 to 1. Okay. So again it becomes 2. So u square, it is again 1. So I think I'm left out with 0 to 2 pi d theta. Again, it is going to be 2 pi minus 0. It is going to be my 2 pi. So the answer is going to be 2 pi here. So look, it is a very simple problem that I'm heading the solution to be also 2 pi here. Okay. So this is a simple problem that we are discussing based on what? The area between the two curves. No, because you have a circle x square plus y square equal to 1 and x square plus y square equal to e. So what is the area between that? So now we have another one problem. So here the value of the integral. Now we are asked to find the value of the integral. So how to find the value of this particular integral? So again, this particular one is involving maybe in an integral I can say that y sine of pi into 1 minus x the whole square dx dy. So in an examination hall, if you are as a student point of view, I'm just telling you, you are just getting this particular question and such a big integrand, no, you have to go on with that. But don't worry, for everything you can take a deep breath and you can go on with that. So you not get worried or annoyed with looking at the question because it's just a question. Okay, so what can you do? See, whenever you are coming across these problems, you take a careful watch about how can you simplify your integrand. So whenever your integrand is a little complicated and you are making you worried, no, you try to make that integrand very simple. So how you can make the integrand simple? So that's the thing. So we'll just go about with that. So here, see y sine of pi. So something it is thing is here. Okay. So here we can make some substitution. I think that works, you know, because when you want to make an integrand simple, the only thing that you can do is you can go for a simple substitution so that you can try to fix certain things. See, when you are dealing with a very big expressions or no, we simply put a very big expression. Let us take that it's going to be a or b, so that it will be simplified. Whenever you are dealing with some trigonometrical functions or expressions, so we try to put it as some a equal to this one and b equal to then tan of a plus b. All those things will be doing it. So in that way, we will try to put this integrand to a simple function and we'll try to proceed with that. So for that, let me take u equal to 1 minus x. Okay. So when I put u equal to 1 minus x, what happens to my du? Minus dx. Okay. So when you start substituting instead of x, then I should be focusing on the limit also. Okay. So when my x is equal to 0, what happens to my u? So 1. Look at when my x is equal to 1 minus y square. So u will be equal to 1 minus y square. Now it becomes y square. So it's a simple move. Okay. So now what happens here? So I can simply say that it becomes 0 to 1. Now this is u. So it becomes 1 to y square. This becomes y. It becomes sine of pi. Instead of 1 minus x, I'm just trying to put it is as u square. Okay. So this is going to be, because your dx is going to be du. So I'll have minus du dy. So this is a very simple one. Now, whenever we are having a negative, we try to settle down that negative first. So I think we can take this. If you change the limits, if you interchange the limits, then you have a negative. So you can have sine of pi u square du dy. Okay. Yes. Now we have applied substitution. We have simplified maybe a very big expression, that very big integrand into a simple integrand. Even you look at your limits, it was 1 minus y square. Now it is y square 1, y sine pi u square du dy. Okay. Now again, if you start integrating with respect to du or with a dy, again still you need it in a very uniformed way. No, we are just go on with that. Maybe with a y, if I am going to integrate, see this is all u limits, because your u equal to y square and this is your y limit is constant. So if you integrate your with respect to y, suppose if I'm integrating with respect to y, I get only 1 by 2. That's the thing. Again, if I respect to u, if I do, no, it is again a complicated one. So something has to be done here. See, again, you check this one. Your u equal to y square, like your x is equal to y square. Okay. Your u is equal to 1. Then your y equal to 0, that is your u axis is going to be there. And your y is equal to 1. Is it not the same diagram that we have done? This is y is equal to 1. This is going to be u equal to 1. And what is this? X square equal to y. So it is u equal to y square. Or I can take y is equal to root y. So y is equal to root u. See, look at the thing. As I was just mentioning earlier, no, definitely you will be getting such a kind of question. You will be coming across this particular one. Okay. So this particular one is very, very important, you know. So here, this particular diagram seems to be a very repeated one, a default member like it is there. You will be coming across this diagram. Now, what I'm going to do? See, I am just going to have the interchange of what? The limits value. So how I'm going to take? I'm just going to take in terms of dy du. So it is du dy. I want in terms of dy du. So that's the understanding. Now how these limits will change? Any idea? Because this is the third time we are looking into this such kind of diagram. Now let me write like this. My integrand is not going to change. And now I want it is going to be dy du. Any idea? So I can write my limit du as 0 to 1. See here, u, please don't say because it is a new variable, like it is like our xy. We have now uy. Now I want the limit of y in terms of u. Any idea?
Y to 1.
Already it is there.
Root to 1.
Yeah, it is 0 to root u. That's it. Again, I'm
Okay.
telling you, it's the third time we are coming across the same diagram. Am I right? See, my question is, I want to somehow make my interchange of limits for u and y. Because I'm changing the order of integration. I'm not going to integrate u and then y. No, I'm going to integrate y and then u. So I'm changing the limits accordingly too. So I have to change about this. So now this is very simple. So we have applied the method of substitution initially. Then from the modified one, we are able to graph this. Why I'm graphing this? Because my integrand is not flexible to me. So I want to go about with a simple one. So I'm going for what? Change of order of integration. Okay. So now you see it is going to be y square by 2. Y square root u, it is u. I'll have on 1 by 2 outside. So I'm just skipping 1 or 2 steps because I hope you can understand it's a repetition. So I think it will be u because it is y square by 2. 1 by 2 is outside. Y square, it is u. Now it is sine pi u square du. Now we will just take a look at the question. Look at our question. Now you see the simplified version of it. But again, it doesn't stop. You will take u square will be equal to, again, t. So go with 2u du will be your dt. So it is u du. It is going to be dt by 2. So obviously, it is again 1 and whenever we have the limits as 0 and 1, no? And such kind of substitution, it helps us to retain the same limit. So it's not a problem. So I have 1 by 2 you will have, 0 to 1 you have. So u du alone, it is dt by 2. So it is sine pi t, dt by 2. So it is going to be 1 by 4, 0 to 1. It is going to be sine pi t dt. So now can anyone give an solution to it? If I'm going to integrate this, it is going to be cos pi t by pi. We'll have a negative sign too. So it is going to be minus 1 by 4 pi. So it is cos pi t. It is 0 to 1. you have minus and minus of minus 1. So again, I think I will be having 2 by 4 pi. That's going to be 1 by 2 pi. So this is the answer. See, this time also no, we are getting the option A to be the answer here. So this is a way for it. So maybe I can give you in a nutshell about the other two problems so that how you can make this problem very simple. So I'm not going to go with a detailed expression for it because I have another one problem with that. So two problems I'll tell you how about to go here in a very nutshell, simple way to proceed with that. It all matters how you understand the question. Okay. So again, G is the region in R square given by, look that thing one. This G is a region, the same pattern like we are getting. Okay. So same pattern like we are getting, G is a region, same way, the same circle is here. But here you have this particular part to be what? A different one. Now what are we asked to find? We are asked to find actually the value of this particular one. Okay, what is this then? See, it is very simple, no? See, something x square plus y square, whenever you are getting that, it is an indication that it is a circle. No doubt in that. Whether it is equal or less or whatever might be, x square plus y square, it is a circle. Okay, that is an understanding to me. Now, region. So circle, region. Okay, I have to go with the polar form. Okay, when x is equal to what? R cos theta. What is my dx dy? That is going to be my r dr d theta. Okay. Now, what about your radius? It is going to be there. What is your r? So maybe it is less than 1. Okay, fine. And just to take it as 0 to 1 here. It is rating. Maybe there is an upper limit. No, it does not go more than that. That's the upper limit. It will not go beyond your 1. So it is less than 1. So fine. So we start with the radius. It is 0 to 1. No problem. Now theta. Now theta. Okay, theta. Why can't I take 0 to 2 pi? Yes, you can take 0 to 2 pi. This is fine. But what about this one? We have not even focused this. All our what is it? All our interpretation of all those things lying from only this. But we have not focused this particular part. What is this part? Okay, then how about with that? See, when I take x is equal to r cos theta, I have to take y is equal to r sin theta. So if I want to have tan theta, it is going to be y by x. So theta equal to tan inverse of y by x. Okay. These are some common facts, basic facts. Why am I mentioning here? Why do the need to mention here is, look at this particular inequality. X by root 3 less than y less than root 3 by x. So something theta connecting y and x and tan. Okay, fine. Now, how you can bring this? So maybe I can write this here like, can I take it as 1 by root 3 less than y by x less than root 3? So what is your y by x? It is tan theta. Okay. What is your theta? Then your tan inverse of 1 by root 3 less than theta less than tan inverse of root 3. So now what are the values? So this is going to be pi by 6 less than theta less than pi by 3. So I got my theta 2. So now this is your g x square dx dy. Let me first find this. Then 200 by pi I can look into it. So this is going to be what? So this is going to be r square cos square theta dx dy r dr d theta. So it is 0 to 1. It is going to be pi by 6 to pi by 3. So look, from the given g, you are able to find the limits of your r and limits of your theta. Okay, so this additional info is given here. Now r cube. So again, you go with the integration r cube. So it is going to be r power 4 by 4, no? Because r cube. So you have 1 by 4. So r part got over. Now which part remains? So cos square theta d theta. This remains. So cos square theta you integrate. So I have to bring it to the trigonometry. I was telling you the substitution. So 1 plus cos 2 theta. So theta by 2, then again sine 2 theta and all those things. So I want you people to go on with this integration up of limits. So we are getting the answer to be pi by 48. I wanted to check. But what are we asked to do that? So 200 by pi of this answer. So what is this answer? This is going to be pi by 48. So on simplifications, you are getting approximately some 4.17. So this is a very simple problem here. So we'll go with the next problem. So simple again, you will go with a multiple integral. Find the volume of the solid region in R cube bounded by the hemisphere. We have given hemisphere and what is bounded below by the cone is it. So here also, what we are going to do it. So whenever you are getting x square plus y square, you don't have a second thought of mentioning this to be your R. You can take z equal to root of r square. So z equal to r. So z equal to, it is 1 plus root of 1 minus r square. That's it. It's very simple. So now you talk about your dv. So multiple integral, it's a volume of the solid sphere. I was telling you, you want to find the solid sphere. So what is your v then? So in this case, it is going to be your dv. So when take about your hemisphere, when take about your cone, so you can take your dv to be your r, dz, dr, d theta. So this is an understanding here. And you can go with the triple integrations, because you're going to find the volume. So the volume will be, it is r, dz, dr, d theta, because previously you have not used any representations for this one. So when you talk about your hemispheres and all those things, when you talk about this one, then definitely this is going to be an integrand. So here it is going to be your r2, 1 plus root of 1 minus r square. So since it is going to be your 1, so and it is going to be your 0 to 2 pi. So I want to just go with the integration of these two and the final answer. So what you're just going with that, it is going to be the answer is pi. Okay. So these are some of the common problems that we have been seeing. And what I personally feel is, if you are just going to focus on your integral calculus, don't ever miss off focusing on the change of order of integration and surface area as well as the triple integral, because the rest all of the problems falls into the same thing. So I think we have gone across many problems and how to proceed with that. So I like to finalize and give a summarizing of this one. Personally, after looking into some 3 to 4 years of question papers of your IIT JAM with respect to integral calculus, so what are my observations? See, the problems are very direct sometimes, and sometimes they're a little tricky, but it is not too tricky to catch out of it. It is easy when you draw a graph, okay, and then finding out the limits. And changing of the order of integration is not essential every time, but see to that whenever it is needed, you graph it, find suitably the limits of it, and you proceed with that. And be very quick in calculating the integration part. If you take so much of time, because when we come across a problem, we have too many substitutions. So that's not a little laborious, it will be lengthy will be there. So I personally ask you people to have a repetitive practice. So it is not that you have a problem, okay, it is easy, I can manage it. No, it is not point of managing it. It is managing within the time frame. That is more important, because when you spend a lot of time in simply integrating the things, I think you will not be able to solve the remaining problems. So be quick in integrating. So use the substitution method and use the integration by parts very quickly and try to be very familiar with the trigonometric functions, because for substitution you'll be using it. And so this is from my end. So I wish you all the very best, dear students, for your forthcoming examinations. So really, I feel that it is an honor to me. I always used to say, sir, it's really an honor to me. You are doing a very wonderful service. And today, I feel it is a very blessed day because I got an opportunity to be a part of it.
Thank you. Thank you, Dr. Nivetha. It will be better if you could turn your video on. Thank you once again. Thank you, Dr. Nivetha. You have explored some nice problems and with nice explanations, and also you have given some directions how to prepare for the questions from the integral calculus part. I think it will be really beneficial for those who are seriously preparing for the IIT JAM examination. Dear participants, now it is a time for feedback. I welcome the participants to share your feedback.
Hello everyone, good afternoon.
Yes, Aisha.
Ma'am, before that I have a doubt in finding the theta limit, ma'am. If possible, could you check in your slide page number 70? You said 0 to pi by 2, remember, ma'am?
Okay.
Ma'am, could you hear me? Yes, ma'am. Ma'am, in the question, they have mentioned that it is first octant. First octant means the circle, it will be divided into 8 parts. So the theta limit will be 0 to pi by 4. But in that question, why we are taking 0 to pi by 2, ma'am?
Yeah, it's a good question. See, what they are trying to say is, there you talk about first octant. When you will talk about your octant in the sense, no, you will talk about your octant in your three-dimensional one. Am I right?
Yes,
So
ma'am.
three-dimensional one, you talk about your octant. So there you have your X, Y, and Z. So that particular part, when it is being projected onto your XY plane, when you're going to project it on your XY, the vertical projection of that particular area into your XY plane. Because see, when you're talking about your triple integral, when you take your Z limit, it's fine, you are convinced. But when you focus on your XY, that is where dx, dy, it falls on actually what? It is an area. So where that particular part, that is the area or the portion where you talk about your octant, x greater than, y greater than, z greater than, that vertical projection, if you take into your xy plane, so here you will have a quarter of a circle. So that's an understanding. So that particular disk, what is being formed, the circular disk, that particular part will be a quarter of it. So it is a projection of that particular region, whatever falling into the first octant, into what? Your xy. So this is what I'm trying to say that. So there it is going to be a quarter of the disk. So for a quarter of a disk, what could be your theta value?
0 to pi by 2.
Yeah. So that is the thing. Because we are focusing on the limits of x and y for the region which is falling or projected into what? Your xy plane. So this is how you will find the limits of what? Your triple integral from your x and y. I hope it's clear now.
Yes. Yes, ma'am. Yes, I'm getting the image of it. Yes, ma'am. Ma'am, also I have another doubt. There are some questions in which it is not direct. They will be giving it in a set builder form. For example, I have this question, ma'am. Can I ask the question, ma'am, from previous year question papers? Can I ask it now, ma'am?
I think, Aisha, you can share that questions. I will forward that to Dr. Nivetha.
Okay, ma'am. Okay, sir. I'll share it now, sir.
Yeah, I think
Now,
that will
can I share it or later on, sir?
Yeah, we can solve it later, I think.
Okay, okay, sir. Sure, sir. Thank you, sir.
Okay. Thank you, Aisha, for your
Yeah.
feedback. Participants are encouraged to share your feedback with video on mode, if it possible.
Hello, sir. Hello, ma'am. I'm Chandana.
Yes.
Ma'am, your today's topics was all crystal clear for me. Thank you so much. Your teaching was amazing. I love the way of your teaching. Thank you so much, ma'am, for your wonderful teaching. And thank you, sir, for conducting this session.
Okay, thank you, Chandana.
Sir, good afternoon, sir. Good afternoon, ma'am. I'm
Good afternoon.
Reshma. Yes, sir. First, I want to thank you for conducting such a wonderful session. The instructor explained everything very clearly, step by step. They not only solved the problem but also demonstrated them using GeoGebra, which made it easy for us to visualize the concept. The use of graph and visual explanation was incredibly helpful and engaging. The class was organized in a way that made it easy to understand. That instructor also provide their guidance on how to study integral calculus effectively and highlighted the key areas to focus on, giving us in clearly understanding on how to prepare for this topic. And thank you very much, ma'am and sir, to such informative and interactive session. Thank you, sir. Thank you, ma'am.
Thank you, Reshma.
Yeah, thank you, Reshma.
Good afternoon, ma'am, and
Yeah.
good afternoon, sir. The session was very nice, and starting problem was very nice also. Some in starting problem was looking difficult, but when ma'am solved and told about some tricks and fundamental form of algebra, fundamental form of calculus, then it will be easy. And some pictorial form of by some software and latex also. And I want to ask about some textbook and reference book also, and what we should do in last 4 months also.
Actually, thank you. Sir actually shared the previous year question paper. I think you can have those for the question papers. And I should really say that presently, so many people are actually working on with solutions. Very live interactions are going on. And specifically the textbooks, I'm not much aware of the textbooks because there's integral calculus. No, you have many number of textbooks are there. What we have it actually is in our academic way. But more specifically, no, understanding the crux of what is the problem. So what they are actually asking. So that particular knowledge we need to have, including every one of us should have. So I think it's a good you go on with the previous year's question papers. You take a thing, because what I personally suggest is, or what will I suggest my students is, if you're focusing on one area, is obvious integral calculus, you start collecting the other questions, at least some 5 years of questions using. Definitely you'll be able to track a pattern of it. There will be some questions will be asking repeatedly, or a pattern. I was telling the G type of problem. So those problems are there. So you yourself can make a pattern of it. And nowadays, people are working a lot more of explanatory, like what sir is doing a very good initiative. So many of the professors, out of their interest, they are coming out and they are giving a lot of insights regarding the problems. And if you can also effectively use of so many helplines are there, like you say that. So you can make use of that and you can get a solutions and you can start preparing. All the preparations, I personally feel it starts from the self. So we have to sit and we have to solve the problems and we have to understand. And if you have any doubt, you can share the problems to sir. And I'm very much ready to solve and give the solutions in whatever way you wish. Either it will be in a solved form or in explanatory form. So I'm ready to give my assistance and my support.
Yeah, thank you, ma'am. Thank you, sir.
Thank you, Dharmendra. Others? Yes, Neha.
Hello, sir. Hello, ma'am. Good afternoon. I want to say that this session was very nice. Mainly, I feel difficulty in volume of solid by triple integral, but as ma'am have shown everything by graph, so it uh, becomes very easy to understand, and my all concepts are now clear. And thank you, ma'am, for this session, and thank you, sir, for conducting this session. It is very nice to understand everything. You have explained every concept very uh, detailed manner. So thank you for that.
Yeah, thank you, Sneha. Any others?
Hello, sir. Hello, ma'am. Good afternoon. Today's session was very good. It makes me understand all the concepts clearly and all the questions. It became easier to understand. Thank you for organizing this session, sir. Thank you, ma'am, for this session.
Thank you, Sneha. Any others? Okay, once again, thank you to Dr. Nivetha for being with Math Aspirants and for the nice words about our group. It's really encouraging to do more this type of programs. I also request Dr. Nivetha ma'am to help us to reach more students from your areas like Tamil Nadu and other states. There may be many people who belong to, not having that much financial background to go for coaching and all that. So I think this type of initiatives will be really beneficial for those who are seriously preparing for this type of competitive examinations.
Sure, sir. Some of our students are there in a group. So definitely I will encourage a few more students also, the forthcoming students, the final year students, definitely to join our group, sir. Certainly.
And it will be good if you can share the PDF of this today's session. We can share it with the recording of this class.
Sure, sir. Sure, sir. I will.
Okay, once again, thank you, Nivetha, and all participants, and wish all participants all the success in the coming examinations. Thank you, everyone.